Welcome to this video on importing modules and the standard library of Python. As you can see, one of these scripts here has been designed to represent a module. When it's launched, it prints the statement imported fun module, it's party time. Then there's a party time statement that's been cast to a string that says let's code like it's 1999. That's binary representation of that decimal number. As you can see, the partification process is really quite simple. Just append some fun designs to it. Below this module script is another one called mainpage.py. This first module is passed an array of quote-unquote boring words, and then some function calls to the fun module to partify those words. As you can see, once it's launched, the import fun module statement is printed to the screen, and partified versions of the quote-unquote boring words are also printed to the screen for fun. This next example demonstrates a shorter version of how to import these modules. And by shorter, I mean just making the name of the module a little shorter. It functions the same way, just in this example I've passed in a different array of quote-unquote boring words. And here's a different implementation where you take specific functions out of the module. So as you notice, the statement says from fun module import partify word before and after party time, and I'm making specific function calls to these different functions within that script. Here's another implementation where you're taking specific functions out, but you are casting them to different names. Partify word, I've shortened to PW. Party time, I've shortened to PT. You can see they still function the same, it's just saving a little bit of that coding landscape in the script itself. When a Python module is imported, Python uses the system file path to locate that module. One way to see the actual path that's being used is to use the import sys statement and then print sys.path to the console. In the above example, this script has been named Where is Waldo module. Unfortunately, the label's a little bit cut off for the purposes of this video, but you can take my word for it that this is the name of the module. You're seeing the path that Python checks when it's looking for modules, including the one that we have just created. As you can see from the output of print sys.path, Where is Waldo module is not there. So when you try to import it, you see a module not found error printed out to the window. So one way to resolve the module not found error is to append the file path to the system path. As you can see, it has been appended to the end of that file path. And now when we run the import statement, it's successfully found. So when Python begins this process of searching the file path, it searches through the directory that the import statement is being called from. The Python directory search proceeds like this until the module is found. First, it searches the directory that the running script is in. Second, it searches for directories that are listed in the Python path environment variable. Third, it searches through the standard library directories. And fourth, it searches through the site packages directory that handles third-party packages. Another way to make this adjustment is to actually make an edit to the bash profile. You can do so within the terminal. Simply add the statement export Python path in all caps, one word, no spaces, equals the file path directory that leads to that module. I'm doing this in nano, so Control O overwrites, Control X exits. Now, as you can see, after importing sys and printing the sys.path, this file path has been prepended to the file search path and successfully imports the module. Next, we're going to show you how to go ahead and do the same process in Windows. To begin with, we look at the Python path that's within the Python shell. When we try to import where's Waldo module, we get the module not found error. So how do we resolve it? It's really quite simple. First, I'll show you that it is located on the desktop within a folder called Waldo module. In the search bar at the bottom, type in env for environment and click on Edit the System Environment Variables. Next, click Environment Variables. In the top window, select New and put a variable name of Python path in all caps, and then input in the variable value the file path that leads you to the Waldo module directory. Note that this file path may be different on your personal machine. Now that this file path has been added as an environment variable, select OK to close. Close it again with another OK, and let's try it one more time. Within the Python shell, start with the import sys. You can then put a semicolon to continue another command, then type sys.path and note that it has been added successfully. Let's try that import where is Waldo module statement one more time. Success. Very nice. Note that this can also all be done within command prompt. Let's input Python to start the Python application. Import sys, semicolon sys path to see the path. Zoom in for a little bit clearer view, and you can see once again the import where is Waldo module functions.
Let's talk about the standard library. Why do we want to use it? Because it saves us a ton of time and offers a tremendous amount of functionality.
For instance, random is part of the standard library. It comes with Python installation process. We'll give it a try by using it to randomly select one of the quote-unquote boring words and pass it into the random partified word function call, where we have reduced the name partified word to simply pf. As you can see, it has randomly selected one of the elements within the array. When you run it again, it selects another element in the array. Run it a third time, it selects another random element within the array. Another great module that you can think of using is the math module. It's also one of the standard library modules. It'll save you a ton of time. Let's start out by looking at all the different options available within the math module by using print dir math. For instance, factorial. It's a really common practice to program this function, so I'll show you the difference between a naive factorial approach and simply using standard library module. So here we've got the naive factorial implementation that takes an input number and does a few if, elif, else checks, and then makes a recursive call at the bottom to process it. So the difference is you can write all those lines yourself and then call it, or you can simply import math and use math.factorial. Here's an example of how you can use the standard library to save you a lot of time. Both give you the same answer, both are correct. Next, we're going to show you something involving OS. The operating system module is another great module that comes with the standard library. You can use os.getcwd to get the current working directory and print it to the screen. Additionally, you can see where the os.py file is located by printing os.dunder file, where dunder means double underscore. Now with the terminal to the right, we're going to navigate to that file. Now we'll open it to show you exactly how it's implemented by these Python experts who built it. This is something that you can do in your own time to get a look at how they've constructed these standard library modules. As you can see, within the output window, We're going to locate os.py. And now I'm inputting nano space ospy to launch it in a nano text editor window. Here we go. It has now been opened in GNU Nano 2.0.6, where you can take a look at how these developers have developed this implementation of os.py. Thank you for watching, and visit upe.uconn.edu for more great tutorial videos.